In this video, we are going to learn how to apply the rules from trigonometry to find the lengths of sides of right triangles. So for those of you who've been kind of wondering, why do we memorize all these definitions and we make all these stupid fractions? Now you're going to find out. So let's jump back. If you've seen some of my previous videos, you saw a problem where my dad measured the height to the top of a tree and he found out it was a 70-degree angle. He was standing 10 feet away from the tree and he wanted to find the height, okay? And I made the point that all right triangles with 70-degree angles are similar to all other right triangles with 70-degree angles. Just like all 30, 60, 90 triangles are similar to each other, just like all 45, 45, 90 triangles are similar. The difference is we didn't memorize a bunch of rules for the relationships of sides in a 20, 70, 90 triangle, okay? Trigonometry basically will allow you to store all of the relationships between sides of right triangles with different angle measures in your calculator. Pull those up and use those to solve problems, okay? So here's how this is going to work. And just a quick review here, at the end of my last video I discussed the idea that a lot of people use the term SOHCAHTOA, and you hear all kinds of funny stories about people's Native American family members and that kind of thing. Anyway, whatever you want to use to remember that word, you need to know the word SOHCAHTOA, okay? And what SOHCAHTOA tells us is that the sine of an angle is the fraction comparing the opposite side and the hypotenuse. The cosine of an angle compares the adjacent side and the hypotenuse, and the tangent of an angle compares the opposite side and the adjacent side of that angle, okay? So how's that going to apply to this problem here? Well, basically, you're always going to have two side lengths of a right triangle and an angle measure, okay? Two side lengths and an angle measure. And you're typically going to know two of them, and you're going to be finding the third, okay? The examples I'm going to look at in this video, we're always going to know the angle measure and one of the sides, and we're going to be trying to find a third side. And it's very simple. You just take your angle measure, and it has to be one of the acute angles. Don't use the 90-degree angle. And you just decide, using this angle, would I have a sine, cosine, or tangent relationship between the two sides of the triangle I want to look at? And by the way, you could use the 20-degree angle and do the same thing. It'll change your rule, but it would also give you a right answer in the end. But since I started with the 70, I'm going to use the 70, okay? So I go to my 70, I go across from it. That's the side that's opposite the 70-degree angle. And this is the 10-degree angle. It's next to the 70-degree angle. So that's the adjacent side, okay? So use the angle that you're going to use in the problem. We have an opposite side and an adjacent. And if we look over here, that's a tangent relationship, okay? So I'm going to be using a tangent equation. You're always going to figure out, is it a sine, cosine, or a tangent? And then we just fill the values in, okay? So you take the sine, cosine, or tangent of an angle, okay? So we are going to take the tangent of a 70-degree angle here, okay? And it's going to be equal to the length of the opposite side divided by the length of the adjacent side. So the opposite side is x, we don't know that. The adjacent side is 10, we do know that. Here's where the magic happens, all right? You are going to go to your graphing calculator or scientific calculator, okay? Can't be some $2 Kmart calculator. Is Kmart even a place anymore? Anyway, it can't be your $2 Walmart calculator. Graphing calculator is great. If you have a scientific calculator, the key is it's got to have the sine, cosine, and tangent buttons on it. It'll do everything that we need to do for this unit then, okay? Number one, if you have not used your calculator before, you need to check, and it's going to be tough to see here, but you need to check the mode button, which is probably right here on a lot of your calculators. Hit the mode button. In mode, you see something that says degree and radian. Make sure degree is highlighted, okay? And if you have an older calculator, you're using like just a straight calculator, old calculator, a lot of them have a button that says DRG on it, and in little letters, you'll see something that says DEG or RAD or maybe GRAD up in the corner of the screen. And make sure that your calculator is in degree mode. So hit that, hopefully your calculator says DEG somewhere. Just to check, to make sure your calculator is in the right mode, because there are different ways of measuring angles and it can confuse your calculator. Type in the sine of 30 degrees. The sine of 30 degrees should be 1/2, okay? If your calculator doesn't say that the sine of 30 degrees is 1/2, then your calculator's in the wrong mode, Okay, so again, you've got to be in degree mode, and if you have to, Google it or something for your particular calculator model if it doesn't match mine. But the mode button on the TIs, which is what you're supposed to have, is right here. Okay, so here's how this works. You go to your calculator and you type in tangent of 70, okay? And my calculator tells me that the tangent of 70 is about 2.747. I would take this out at least 3 decimal places, if not more. I think I'm going to go 2.74747, okay? And the decimal's going to continue. If you can keep the decimal in your calculator, that's really best, okay? And that's equal to the other side of the fraction, which is x over 10. If you remember when I did this problem where I drew my own 70, 20, 90 triangle on paper, the ratio between the base and the height worked out to be about 2.75, okay? That's what your calculator is storing, okay? So what you're really doing is you're going to your calculator and you're saying, hey, calculator, I've got a right triangle with a 70-degree angle. I want to compare the long leg and the short leg. What should that ratio be if I divide these two values? How much taller should this side be than that side? And your calculator just has all that memorized and it kicks you back that number. That's what's happening, okay? So you run that on your calculator, you replace it in the statement, and now you just solve this little equation, okay? That's why you took Algebra 1 last year. X is being divided by 10, multiply both sides by 10, and x in this case is going to be about 27.74. You need to read the problem. Most of these problems are going to ask you probably to go to at least 2 decimal places, maybe more. We'll go to 2 decimal places. We'll say it's about 27.75 feet. That's the height of the tree, okay? So that's the basic idea. Let's take a look at a couple more examples here. I may do a separate video with some other examples, but just to kind of see some of the different things that could happen here. All right, example number 2. Okay, so say I've got a right triangle. Maybe I'm making a ramp, and the ramp is making a 10-degree angle with the ground. We've got a right angle there. Maybe the ramp is hitting the ground 12 feet from the wall, and I want to know how high this ramp will reach, okay? So same kind of thing as before. You decide if you're working with a sine, cosine, or tangent relationship. So you take your angle, and you could use the 10 here, or you could use the 80 over here. It does not matter. You'll get different rules, but you'll get the same final answer. And you decide, what rule are you working with? So I have the opposite side here. I have the adjacent leg here, okay? Opposite and adjacent, that's the tangent rule, okay? This is actually the same setup as the previous question. So you take the sine, cosine, or tangent of the angle measure, and that's going to be equal to the opposite side over the adjacent side, which is going to be x over 12, okay? And you go to your calculator and you say, hey, calculator, I have a right triangle with a 10-degree angle, and I want to know the ratio between the opposite side and the adjacent. So you type in tangent of 10, and your calculator is going to tell you that it's about 0.1763. Again, I would try to keep that in your calculator if you possibly can, and that's equal to x over 12. Okay? Now think about this. What this is saying is if you take this side and divide it by this side, you should get about 0.1763. In other words, this side is much shorter than that side. Okay, and that should kind of be backed up in what you're seeing in the picture. Okay, so at this point, I just solved the equation. X is being divided by 12. I multiply both sides by 12. I'm keeping that tangent of 10 in my calculator, and we're going to get that x is approximately 2.12 units long, okay? So about 2.12 units. Now, I could have asked you something different. I could have asked you to find, you know, maybe how long is this ramp going to need to be to go at this angle and reach up to that point. So let's call that side y, and let's see if we can solve a trig equation with the same data but to find a different side length, okay? Should involve a different rule. All right, so I'm still going to use my 10, but if you want to use the 80 up here, it'll just give you kind of a different ordering of things. Okay, so we have the adjacent leg, adjacent next to the 10-degree angle, and we have the hypotenuse, okay? Adjacent and a hypotenuse, that's a cosine relationship. So I'm going to take the cosine of 10 degrees, and that's going to be equal to the adjacent leg divided by the hypotenuse, okay? That's going to be 12 over y, okay? Same kind of thing. I go to my calculator, I say, hey, I want the cosine of a 10-degree angle. And again, my calculator is going to tell me what the ratio between this side and this side is. By the way, if you notice, these two sides are both very long. their lengths are going to be pretty close to each other. So I'm expecting to get a value that's pretty close to 1. Okay, and sure enough, when I put that in my calculator, I get about 0.9848, we'll say. And again, I would keep the decimal in your calculator. That's equal to 12 over y. Now, here's where you need to be careful. This is something that I would normally poll the class, and I can't, so you're just going to have to kind of watch on the video. You need to be careful here. In the last example, x was on top of the fraction. Y is on the bottom of the fraction, okay? People get in a hurry and they go, oh, I'm going to divide by 12, or I'm going to multiply by 12, or something like that. If you get rid of 12 here, you're going to be left with a 1 over y, okay? That's the reciprocal of y. I don't want to know the value of 1 over y. I want to know the value of y, which is y over 1, okay? So you have a couple of different options here. If you think back to Algebra 1, you don't want to have your you don't want to have your variable in the denominator of your fraction, okay? You want to get the y out. You want the y in the top of the fraction. So 12 is being divided by y. You could multiply both sides by y, okay? And that's going to bring a y over here. And now you're going to get 0.984 times y is equal to 12. You can divide both sides by 0.9848, and that's going to give you your answer. So y is going to be approximately, and by the way, I'm going to do 12 divided by, I'm going to use the answer button on my calculator to keep that full decimal that I got from the previous answer there, because it actually goes past 4 decimal places. And anyway, I'm going to get about 12.19 units here, and that should make sense. It's the hypotenuse. It should be a little bit longer than that side, but that 10-degree angle is so small. This is going to be very close to that, and it makes sense. So if you draw a picture that's drawn to kind of to scale, you should be able to see, does your answer make sense? If you're getting a hypotenuse that's shorter than one of the legs, you know you did something wrong. If you've got a leg that's opposite the smallest angle, and it's not the smaller of your 2 legs, you know you did something wrong. So there's a lot of ways that you can kind of adjust and figure out if you made some kind of mistake when you're doing these problems. Okay? By the way, one other way you can do this, if you don't like trying to figure out whether or not the variable's on the bottom and how to handle that, you can also just make it into a proportion. Do cosine of 10 over 1, and that would be about 0.9848 for the cosine of 10 over 1 equals 12 over y. And you can just cross multiply. And when you cross multiply, you're going to get the same equation that we had, and then you could solve it. So you can always make this into a fraction on the other side and just do proportions, and it'll work out great. Okay, let's do maybe one more example here. All right, let's see here. So let's say I have a 25-degree angle, and let's say that I have an x here, and let's say this is 10. Okay, same kind of thing. I've got to figure out the rule. So I've got an opposite side based on my 25-degree angle, and I have a hypotenuse. Okay, so it's going to be a sine relationship. Sine of the angle is equal to the opposite side over the hypotenuse. Okay, run the sine of 25 on your calculator. Your calculator is telling you that that ratio should work out to be about 0.4226. Okay, x is being divided by 10. I want to get x by itself, so I'm going to multiply both sides by 10. And again, I keep that number in my calculator, and I get approximately 4.226. And again, look at where the problem asks you to round and round to that many places. Okay, that's how that could work. Let's see here. If I wanted to do another situation here. Oh, here's another thing you could do. So you don't have to use the 25-degree angle. Okay, 90 minus 25 is 65, right? That would be a 65-degree angle there. So if you don't like the angle that you're given, you can use the other angle and set it up. So like, for example, if I use the 65, I have the leg next to the 65, which is the adjacent side, and then I have the hypotenuse. And that's going to turn it into a cosine problem. So I could do cosine of 65 is equal to the adjacent over the hypotenuse. And the interesting thing is you're going to get different decimals, and every step along the way is going to be different. This is about 0.4226 is equal to x over 10. But then when you multiply both sides by 10, notice you're going to get exactly the same answer that we got before of about 4.226. So you can use either acute angle. Don't use the 90-degree angle. Nothing will work, none of the rules will work, nothing will make sense. But if you use either one of the 2 acute angles, you should get answers that work out. So that's the basic concept. These are not terrible problems. They're pretty short, pretty quick equations. Once you know how to pick the rule, obviously you have to have a calculator, and once you know how to solve the equations, these can work out really, really nicely.